Hi everyone, it is the last video for chapter 2. We covered a lot in this chapter, so I decided to give you some photos to review it a bit. And also we're going to look at all of these ways of looking at time in the sky and look at how a person who didn't have access to a pyramid in their backyard or who didn't have access to lots of stones up at Stonehenge or didn't have access to a calendar circle might actually be able to see what the date was. And let's go to it. So one of the things that the engineers in ancient Egypt and Babylonia knew was that they had to measure angles. And they ended up devising tools like the carpenter's square that were very effective and very were precise for their time. Well, if you didn't have those tools because you were a farmer or a shepherd, you had tools right at the end of your hand. And so there were poor man's or poor woman's tools right at the end of your hand for measuring angles. And in one of our labs, we did measure angles. So let's go over this. One pinky finger could be 1 degree of 360 degrees around the circle of the sky, if you turned around in the circle. 3 middle fingers is 5 degrees, and that means held way out. All right. 10 is a closed fist. 15 is fingers wide open. And you can see that this would be something that is really not standard for people. And then 25 is thumb and pinky wide open. And you can see how that would have problems with standards. But this is what was used in 400 BC. And in fact, in your lab, you looked at your meter stick and your shadow, and you approximated the angle of sunlight, which, if you were doing that at solar noon, when the sun is highest in the sky, you would have an approximation of your latitude. If you don't have a meter stick, because you're a shepherd and you don't have a meter stick, you could use your hands, maybe 25 degrees and then 3 degrees and 5 more degrees on top of it. And you can see how this goes together. It's safer to use the meter stick because you're not looking at the sun while you're doing this. And this is actually the concept that led to the development of the sextant. So if you are into sailing, you might be aware of using a sextant, and this is the concept which developed over a few millennium to use the sextant for navigation. You can use this during the day. You can also use these hand tools at night, or you can use a sextant at night. It takes more skill to do that. And you work at night in the same way. You are working from the horizon and you are measuring angles up to the pole star. And when you do that, you are approximating your latitude because you are approximating the angle to the pole star on the celestial sphere. And where you are in the world shows you where the pole star is. For instance, if you were up in northern Canada, the pole star would be just about directly above your head because you're that far north. When we look at the pole star at about 40 degrees latitude, it is off in the sky that is probably about a 40-degree angle. If we were down in Miami, it would be at about a 25-degree angle. So this is a way that you can also use your hands or a sextant at night. It's hard to find the horizon at night, and it's very hard to keep that in mind with the pole star, but it can be done with practice. Now, if you didn't live nearby, like I said, a pyramid or a megalith like the Stonehenge, you could use these tools, and from these tools, you could develop your own calendar. So let's look into that. We know that the ecliptic is Earth's orbit projected onto the celestial sphere. That's what we know. And Earth's orbit is down here in red. Earth's orbit projected onto the celestial sphere is the ecliptic. And if you were in ancient Egypt or in Babylon, you would also notice, because you thought that the Earth was the center of the universe, you would also notice that the ecliptic is the sun's motion along the celestial sphere among the stars. So when you saw the sunlight, you would be seeing the sunlight along the celestial sphere in the ecliptic. And if you were from Egypt and you thought that the Earth was the center of the world, you would look at the sun as doing the moving around the ecliptic. This is important for a calendar because the circle takes 360 degrees, and they realized that every moon cycle seemed to take up about 30 degrees of the sky by the stars relative to it. So 25 plus 5. Every moon cycle seemed to take up about 30 degrees of the sky, and they could note when the moon cycles would change by when the sunrise came up in a constellation just as it was fading away with the day. So they looked for constellations that were about 10 degrees above the horizon at sunrise, and then they made up stories for every 30 degrees. Let me go into that a little bit. They made up stories that were associated with animal migrations, with planting times, with oncoming monsoon rains. There were 12 signs and stories in the Zodiac, just like there are 12 months or moons. Literally, that's where it comes from. So the Zodiac was a primitive calendar that was actually very effective. And you see here that if you looked at sunrise and a little above sunrise, you would see constellations and be able to track a year going by the stories that you knew about in the sunrise. And of course, if you're a shepherd, you're up at sunrise. So for instance, let's look at where you are on Earth on the ecliptic, and the sun is shining its beam in January through Sagittarius at sunrise. Is that so? Well, let's take a look at it. Actually, this is right out of a planetarium program that we're going to be starting to use. And if you look at this, this is Sagittarius. Don't believe me? I'll show you. It's known for this triangle and another triangle and a box. Okay? Triangle, triangle, box. Let's go back. And Sagittarius is the hunter. Okay? So there you go. Triangle, triangle, box. This is Sagittarius rising at sunrise. There's the east. It's rising in December in the southeast. Well, actually in January in the southeast. And that's sunrise right there. So you could tell the story about Sagittarius the hunter. In January, you would know what would be coming next. In March, the view of the sunrise goes through Aquarius. Well, does it? Let's go see. And, oh, here's another planetarium program that shows you in the east in March, which is very close to the equinox. So the sun is going to rise nearly due east in March. And guess what? It's in Aquarius. So you can see how these constellations were linked to what was happening in the world. March and April, that's a section of the zodiac known as the sea, and they're both Aquarius and Pisces are associated with water. What do you think of in springtime? The spring rains. Okay, so that was important. And I wanted to point out to you what's really fascinating. You probably have wondered, I've wondered, what is the Tropic of Cancer all about, and what is the Tropic of Capricorn all about? And it's amazing because 2,000 years ago, June, which is the summer solstice, which is the northernmost point of the sun on the ecliptic at the Tropic of Cancer, guess what? June used to have Cancer as its constellation. And due to precession, remember the wobbling, over 2,000 years, now Taurus is in June. But Cancer used to be in June, and not only that, but Cancer is the crab, and June is the peak harvest time for crabs in Egypt and the Nile. So think of how important that was to those peoples. Also, with precession, you might say, well, what's the Tropic of Capricorn about? That's in the southern hemisphere. Yes, it's in the southern hemisphere. And the winter solstice puts the sun at the Tropic of Capricorn, 23.4 degrees south of the equator, in December, the winter solstice. And so now, because of the precession and the wobbling, now December is right around here, and December moves to Scorpius instead, Scorpius the Scorpion. But December used to be over here and go directly to Capricorn. So that wobbling really has impacted our skies in the last 2,000 years. And I thought you might find that fascinating how the ancients really valued time and let everyone have a calendar. Chapter 2 is done, and I'll see you in Chapter 3.